All right, let's jump right in. No matter what industry you're in, manufacturing, software, you name it, problems are, well, they're inevitable, right? Machines break, defects show up, projects get delayed. But here's the thing. Just knowing that a problem happened, that's not really the hard part. The real challenge, the thing that separates the pros, is understanding why it happened. And that's where this really key shift in thinking comes in. It's so easy to get caught up in the what broke, what went wrong. But the best problem solvers, they push right past that. They pivot to the question that has all the power. Why? Why did this happen? And that question is the very heart of root cause analysis.
You can think about it like this. Anyone can put a Band-Aid on a symptom, but we're not interested in Band-Aids. We're talking about being surgeons, digging deep to find the real source of the problem and removing it for good. And to do that, you need the right tools. So today, we're going to open up the Problem Solver's Toolbox and take a look at 4 really powerful techniques that are used all over the world. So the first tool in our toolbox is, honestly, it's just so simple, but it's incredibly powerful. It's all about being persistent, asking questions. It's called the 5 whys method. The whole idea is you just keep asking why over and over again until you literally can't anymore. You're just peeling back the layers of the problem one by one like an onion. Let's walk through a classic example to see exactly how this plays out. Okay, so a machine stops working. That's the symptom on the surface. So we ask why? Well, because the motor overheated. Okay, but why did the motor overheat? Turns out the lubrication was insufficient. We're getting warmer. Why was it insufficient? The lubrication pump failed. And why did the pump fail? Because it wasn't maintained. Now here's the last most important question. Why wasn't it maintained? And boom, there it is, the root cause. There was no preventative maintenance schedule in place. See what happened? The problem wasn't a bad motor at all. It was a bad process. The 5 whys method is absolutely perfect for a problem that has a single straight-line cause. But what happens when it's not that simple? What if you suspect the problem is more like a tangled web with a bunch of different potential causes from different departments or systems? For that, we need a way to map everything out. We need tool number 2. And this is where the fishbone diagram comes into play. You might also hear it called an Ishikawa diagram. It's basically a visual brainstorming map. You put the problem at the head of the fish, and then your team just brainstorms all the potential causes along the bones, and you group them into logical categories. Now, to give that brainstorming some real structure, teams often use this framework called the 6 M's. So you'd ask, was the issue related to a person or man? Maybe a piece of equipment, the machine. What about the raw materials we used? Could it be the method or the process itself? Or maybe our measurement system is off. And finally, could it be something in the environment, like the temperature or the layout of the workshop? This just forces the team to think really broadly and cover all their bases. Okay, so you just ran a great fishbone session, and now you've got a whiteboard filled with dozens of possible causes. So, where do you even begin? The truth is, not all of those causes are created equal. Some of them have a way bigger impact than others. And this is where our third tool is so handy. It acts like a filter to help us prioritize. This number, it might look familiar. It represents one of the most powerful rules in all of business and quality management. It's called the Pareto principle. Simply put, the 80-20 rule says that for a lot of things in life, about 80% of your problems come from just 20% of the causes. Now, the big takeaway here is not to try and fix everything at once. The goal is to find and fix that critical 20%, what we call the vital few, because that's going to give you the biggest bang for your buck. And a Pareto chart, like this one, makes this concept crystal clear. I mean, just look at this example. You can see in a second that poor welding is causing way more defects than anything else. Instead of wasting resources on all those other little problems in that long tail, the team knows exactly where to focus their energy to make the biggest difference. It's all about working smarter, not just harder. So, we've found the root cause, we've used Pareto to prioritize it, now what? Well, the final piece of our toolbox isn't really about analysis at all. It's about taking action. But even here, there's a really important distinction we need to make between 2 different kinds of action. On one hand, you've got corrective actions. These are totally reactive. A problem has already occurred, and our job is to fix it. So, repairing that broken machine, that's a corrective action. But then, on the other hand, you have preventive actions. And these are proactive. They are designed to stop problems from ever even happening. Remember that maintenance schedule we talked about earlier? That's a preventive action. It ensures the pump never fails again for that same reason. And this idea, it really gets to the very soul of modern quality management. You see, great companies don't just get good at fighting fires, they get good at fireproofing the whole building. The ultimate goal is always to shift from a reactive state of just fixing things to a proactive state of preventing them. So let's do a quick check of our toolbox, right? We've got the 5 whys for digging deep on a single issue. We've got the fishbone diagram to brainstorm wide when things are complex. We have Pareto Analysis to help us focus on what's truly critical. And finally, we have corrective and preventative actions to solve the problems of today and stop the problems of tomorrow. So why does getting good at this stuff matter so much? Well, the benefits are just massive. When companies really embrace this, they see those annoying recurring defects just disappear. Their whole operation becomes more stable and predictable. That means product quality skyrockets. And because you're creating less waste and doing less rework, your costs go way down. It is a win-win-win. And that kind of brings us to our final thought for today. Are these just a few techniques that you pull out of a drawer when something goes wrong? Or is root cause analysis something bigger? Maybe it's not a tool at all, but a mindset, a whole culture built on curiosity and a relentless desire to always be getting better. What do you think?